buffer. So when this call happens, Connect will go to my program will go to the buffer in the Connect memory and see if there is a frame there. If there is a frame there, it will bring it back. If there is no frame there, if the buffer is empty, this wait time, whatever you provide in milliseconds, is going to say, block the program for, in this case, 1000 milliseconds or 1 second, wait for a frame to get generated, and then bring it back, right? But what I'm going to do now is I'm just going to be like, I'm going to put a value of 0, saying, I don't want you to block the program. If there's no data in the frame buffer, just come back, it's fine. We'll go back and get the new data, right? So that's all I'm doing. It's just one line of code that basically tells my program to go to the Connect memory, grab a video frame buffer, and bring it back. That's it. I'm going to hit F5 now. So it really doesn't look like it's done anything, but if I click this button, I hope it doesn't throw an exception. Okay, actually, it's interesting. It's not doing anything. And I will tell you why. Okay, any guesses on why it's not doing anything? For those of you that have programmed WPF for, it should be pretty obvious. I'll tell you why. Because it's going and getting the next frame, but what is it doing with it? Nothing, right? I saw a head not there. It's doing nothing with it, right? What we need to do is we need to take this and assign it to the image frames. You see, image has a property called source. We need to take that data and assign it to source. Only then will something happen on the screen. It's actually going and getting the data now, but it's just not doing anything with it. So what I need to do is basically do something like this. Image1.source equals whatever data. But here's the problem. Source only takes a well-formed image of type image source, right? It basically needs a proper bitmap or a proper JPEG or whatever. The problem is, the data I get back from this call to get next frame returns something of type image frame. Let me show you. Image frame iframe equals. Okay, image frame iframe equals get this, right? But here's the problem. I cannot pass it straight. Image1.source equals iframe. I cannot do this because the type that this returns is different from the type that this takes. In fact, if I run this now, you see I get a build error because it cannot convert it. And so we'll talk about how to make it into a format that's acceptable, but let's actually look to see what is the data that's actually coming back. So I'm going to delete this line, and I'm just going to say int I equals 0 or something, just to create some random line here so I can set a breakpoint on this, so that we can go execute the previous line and see what happens. So I run my program, I click this button, and now you see my breakpoint got hit, which basically means that this line already is executed. So let's go in and see what iframe is. Iframe we know is the image frame data type. So actually before we do that, let's go into reflector and see what image frame returns. Because remember, get next frame right here returns something of type image frame. So if I click that, it'll tell me what's inside image frame that I'm getting back, right? So what I'm seeing is a few properties. I think the most important properties are these three properties. First one is a timestamp, right? It returns the timestamp at which that image was actually read by the camera, right? It also returns a frame number, which basically is just a sequential number of the frame that was read by the camera. But the most important piece of data is in this property called image. We see it's actually of type planar image. So let's go in and see what it is. And you basically see planar image basically has these properties. It has a width and it has a height of the image. It has something called bytes per pixel, which basically denotes how many bytes does it take to denote one pixel in that image. But most importantly, it has this field called bits, which is of type byte array, right? It's just this really long number, actually this really long array of bytes that actually contains RGB values, right? So that's what bits is. So the data for the image lives in this field right here. So what we're going to do is, let's examine this in terms of what we actually got back. So you see in my image frame, I get a frame number back of 58, right? Which means after I open, this is the 58th frame that's being captured. My resolution is 640 by 480, timestamp is 1911. Timestamp is basically a number in milliseconds, right? So it basically means this image was captured 1.9 seconds after the camera was opened and stuff like that. But the most important piece of data we saw, it lives in something called image. So I expand this and I see that it has a height property of 480, width of 640, bytes per pixel of 4 because it's encoding in RGB format. R, G, and B are the components for red, green, and blue colors. Each takes 1 byte to represent because the value can range between 0 and 255. But it is inefficient to read 3 bytes of data from computer memory, right? You should read sort of in multiples of the register size of the CPU. So it's sort of getting into computer architecture now. But basically, suffice it to say, it is efficient to read memory in sort of multiples of 2, right? So 2 bytes at a time, 4 bytes at a time, and so on. So reading 3 bytes at a time is not efficient. So what happens is, even though it only needs 3 bytes of data to store red, green, and blue, it'll assign 4 bytes of data, where the 4th byte will always be 0, just so it can read it really fast. So that's your bytes per pixel right there. But the actual data lives right here in bits. And as you can see, bits is just a byte array that is 122, no, it actually is 1,228,800 elements long. And I hope you understand where this number comes from, right? It basically, let's actually see where this number comes from. It's actually just your 640 times 480, which is your resolution of the image, right? These are that many pixels in the image, and each pixel needs 4 bytes. And that is this number, 1,228,800 is this number right here. Right here. So literally, as you can see, it only contains data for each pixel in the image. And if you open it, you can actually see what I'm talking about. Oops, sorry. If you open it, you can see what I'm talking about. So the first 4 bytes are for the first pixel, top left, right? So you can see actually it's stored as BGR. So the value of B, blue is 61, the value of green is 69, R is 63, and then the 4th byte is unused, so it's going to be 0. Similarly, the next pixel is 58, 68, 57, 68, 63, 0. So you'll always find that the 4th element is always 0, right? It's just unused. But the rest are actually valid values from 0 through 255, indicating the intensity of that color channel and that pixel, right? So that is the format in which Connect returns data back. It's just raw RGB data. Now here's the fundamental problem. The format for my image control needs to be a well-formed image. It cannot be raw data. So what we need is some helper function that allows me to take this raw RGB data and convert it into a proper bitmap, right? And so WPF, and that's why I choose WPF to program this, for this demo at least, is because WPF offers me this class called bitmap source that has a method called create, which does this exact thing that we're looking for. It takes raw RGB data or raw any kind of data, we'll see in a second, and converts it into a proper well-formed bitmap that we can then pass on to the image source control, right? So let's go see what we need to supply here. The first thing it needs is something called pixel width, right? We know that the width of the image is contained in iframe dot image dot width. Right, similarly the height is contained in iframe dot image dot height. So all of this data we are getting from the image frame that we pulled back from the Connect buffer. The next property it needs is something called a DPI, dots per inch, which is basically the display density of your screen or display unit. In all cases, except when you get a custom monitor, a high density custom monitor for scientific applications or engineering applications or architectural applications, in all cases, the value for DPI-X and DPI-Y is 96. Ideally, you would get this through the environment variables in Windows, but for simplicity, I'm just going to hard code them as 96 because in about 99.9% of the monitors in the world, this value is 96. The next property it needs is something called pixel formats, and you'll see basically pixel formats is an enumeration of all of the different ways in which you can encode an image, right? So we're basically going to say that I want you to encode this new image that you're creating as a BGR32, right? A blue, green, red 32 format. But you can also encode it in any other different, in sort of grays or with a BGRA with an alpha channel or whatever, right? So you can basically choose the kind of image that you want to output from bitmap source. But for now, I'm just going to say I want BGR32. And the fact that Connect returns it to us in the RGB format means that this is the format that we need to choose. Then it expects an option for something called a bitmap palette. A palette basically is a Windows item which basically allows you to choose custom palettes. You know how in Windows, in fact, let me show you this. In Windows, if you go into, I believe it's personalize, and if you come in here and if you choose window color, no, not this. I forget where it is actually. Maybe it's in advanced. Oh, there it is. Or maybe it's not here. But there's this place in Windows you can go to where you can choose to change the default Windows color if you're either colorblind to a particular color, or if you need like a high visibility format or monochrome format, you can make those changes, right? So those are the custom palettes. So what happens with a custom palette is, if a window comes up and it has a green color, what Windows will do is, if you set a custom palette that takes away the color green and displays it an orange or something instead of a color green, the custom palette will come in and everywhere the screen is painted green, it'll paint over it with the color orange. But at this point, we don't really have any custom palette, so I'm just going to say null. And then finally, it's asking me for the actual array of pixels, right, which is the actual data that needs to get rendered as a bitmap image. And so I know that that data lives in iframe.image.bits, right? Because bits is the big long array that needs to get converted into an image that can then get sent to an image control to get displayed on the screen. And the final property that my bitmap source control needs is something called stride. And I'll explain what stride is. Stride is basically the amount of bytes in one row of the image, right? So in terms of what it is, it's pretty easy to understand. So the amount of bytes in one row of the image can be denoted as iframe.image.width, right? Because this is the number of pixels in one row, times iframe.image.bytes per pixel, because this is the number of bytes per pixel. So multiplying these two gives me the amount of bytes in one row of the image. Now I'm going to take a second and help us understand why stride is important. Now, you saw that the data in bits, right here, it's just this long one-dimensional array. It's just this, series of numbers. Bitmap source or create needs to take this big series of numbers and convert it into a proper 2D image, right? Two-dimensional image. So we need to tell this control or this method how many pixels there are and how many bytes there are in each row, so that after reading that many bytes, it can take all the data that comes after that and compose it as the next row of images, and then as the next row. Does that make sense? When you paint a 2D image, you need to have a stride, right? And that's it. So basically what has happened now is bitmap source.create has taken all of the data that got returned from the get next frame method and converted it into a proper bitmap source, into a proper bitmap. And the best part is, it returns, since it returns a bitmap, I can just feed it directly into my source property of my image. So does that make sense? What I'm going to do is just basically say image1.source equals blah, right? And now if I run my application, it still shows the ball, but now when I click the button, it basically returns that frame, that one frame from the RGB camera. Does that make sense? So let's do it again. Let's actually point it at Heidi. And then, oh, we can't see, not enough lighting. Okay, let's point it at that area which seems really well lit. There it is. You see, so every time I push this button, this call will actually go, grab the frame of memory, or grab the frame, the image frame that's in the connect memory, pull it, convert it into a bitmap source, and send it to this image one's source method. So, sorry? It became a camera, it became a simple digital camera. There you go. Ta-da, ta-da. All that needs is like a little flash sticking up here, and you have a full-fledged digital camera. It's a little too big to put in your pocket along with the laptop, but still, okay, it's a camera. So the key point is, I hope you understand, the key point I'm trying to make here is it actually took us how much? Let me rearrange my code a little bit so I can, all my uninitialized logic, let me move it towards the very end. And so the one thing I'm hoping you get to see is all of the code that we wrote is right here, which literally is 5 lines of code. I mean, it seems more because I've broken it into multiple lines, but in 5 lines of code, I was able to initialize or actually create an instance to my connect, create a reference to my connect, initialize it with the option saying I want to use the data from my color camera, and then I basically open the stream to my color camera. By saying video stream, I'm referring to the RGB or the color camera, and then I open the stream. At this point, at the end of this call, the camera is open, it's continuously reading data. Now, whether or not we use the data is pointless. It's actually continuously reading data, and all the data that it's reading, it's storing it in the buffer, in the frame buffer, right? The number that we set here 2, it basically allocates 2 frames in its memory, and alternatively, it'll keep filling those 2 frames. If you haven't pulled the data, it doesn't matter. It'll just get overridden with the new frame that comes in. It'll just keep writing data in these 2 frames. What we are doing as a response to button 1.click is now we're finally going and reading the data that's stored in the frame. And since we cannot directly display the data that comes back from the get next frame call, we are basically passing it to this method called the bitmap source.create to create a proper well-formed bitmap that we then pass into image one's source property. That's all we're doing. That's basically it. Does that make sense? Yeah? Okay. Now this is slightly, if you think about it, it's slightly inconvenient because I mean it's reading data and all, but I have to keep pushing this button. Every time I want a new frame, I have to keep pushing this button. I think what this allows me to do now is show off the next major thing I wanted to show you, which is basically the events that the runtime class exposes, right? So over here, I basically have these 3 events: video frame ready, which is right here, depth frame ready, and skeleton frame ready, right? So connect basically what it does is after you open the video stream or the depth stream, it will start reading data. And after it reads the data, like we said, it will store it into the buffer, into the memory, right? Immediately after that, what it will do is it will signal to our program that a frame is ready to be read in the buffer. And so at that point, we can go in and read the frame instead of manually pushing the button over and over. and the event that it fires is this right here, video frame ready. So what I can do is right after this call to video stream.open, I can come in and say, I am interested in this event called video frame ready, and I want to subscribe to that event. And the way you subscribe to an event in C# and .NET is by saying plus equals. Right? When you do plus equals, what happens is any method name that follows will automatically get called when this event fires. And Visual Studio is smart enough to realize that I need a new event handler, and it's automatically typed this stuff in. So all I have to do is hit tab. I have to hit tab, and Visual Studio will automatically generate that event handler for me. I mean, it's an empty event handler, right? It basically at this point just says throw not implemented exception. So it's empty. It's really useless. But the structure is already in place. So which means when this event fires, this method is going to get called. Which means what I can do now is this bit of code that I have right here, I can just move it here. Right, so image1.source equals bitmap source.create iframe.image.width. But here's the problem. Iframe is obtained here by calling getNextFrame. But in the event, what happens is the event is smart enough to realize that when the event fires, what we'll be interested in is the actual image frame. And so what it does is it passes the image frame to us as an argument in this named parameter E, in this parameter called E. So let me write the code and we'll look at it in a second. Sorry, I'm going to say the same thing. Actually, you know what? Let me do this. Let me just copy this line of code, paste it here. But instead of saying connect.videostream.getNextFrame, I'm just going to say E dot, and an image frame is already sent for me. So does this make sense? When Connect reads an image frame, it stores it to its memory, fires an event, and sends me a copy of this image frame. Which means my program doesn't even have to go to the Connect and pull it manually from memory. Connect is automatically sending me that copy of data, right? That image frame, that one frame of that image is automatically being sent to me. And then right after that, all I have to do is the code for doing the next thing is exactly the same. I just take that image frame, process that into a bitmap source, and display it in my image1 source, right? Now if I hit F5, let me say one more thing. Now this is going to keep running continuously, right? As soon as I open, Connect's continuously reading, continuously filing my event, continuously this stuff is getting executed. So now if I run the code, what do I expect to see? So almost like video, right? Continuously updating video. There it is. Right, so literally, this here is a very brief video camera demonstration. So it's just basically a sequence of individual frames that just keeps getting updated 30 times per second. So what do you guys think? Any questions so far? All right. So before we move on to the next thing, I also I had a couple of questions before the break about a couple of things that come back along with the video stream, which is, things like in the image frame, things like the timestamp and the frame number, useful for synchronizing and stuff like that. So let me show you what actually gets returned, right? So in my main window, let me go in, and let me go into my toolbox, and let me add a label, right? A small, simple label. Let me move this label here. Let me get rid of my button because I don't need the button anymore. So I have a label here, and I'm just going to copy paste the label again, and I have a label next to it. So this first label I think is called label 1. Yeah, and the next label is label 2. So here's label, I think is label 1. Yep, and the next label is called label 2. So what I'm going to do is I'm going to just print out the information that I get in terms of the frame number and the timestamp in label 1 and label 2, right? So as we get each and every frame, what I'm going to do is I'm going to say label 1 dot content, I believe, yes. Label 1 dot content equals iframe dot frame number. So the first label is going to contain the frame number. The next label is going to contain the timestamp, right? So which means every frame it'll keep getting updated. Let's run this now and see what happens. So you actually see that these values keep getting updated. So this, let me. The point I wanted to make was the frame number you will see gets updated sequentially, right? One after the other. It's kind of hard to read now, but I'll run a smaller demo and show you. It actually updates sequentially, whereas the next number, which is a timestamp, is actually a raw measure of how much time has elapsed between this time, between one frame and the next frame, starting with 0. So where this will become really useful is if you're synchronizing multiple connects, or if you're synchronizing the feed from the video camera and the feed from the